presentation we will discuss about non-exact differential equation and linear differential equation with constant coefficient. So at first we will solve a mathematical problem for non-exact differential equation, like solve the differential equation x squared plus y squared minus 1 dx minus 2xy dy is equal to 0. To solve this, write the given equation and consider this equation as equation number 1. Now we will check this equation is exact or not. For that, we consider m is equal to x squared plus y squared minus 1 and n is equal to minus 2xy. Now partially differentiate m with respect to y, that gives 2y, and n with respect to x, that gives minus 2y. That is del m by del y not is equal del m by del x. So we can say that equation 1 is not an exact equation. Now we should make it exact. For that, we write del m by del y minus del n by del x by n, that gives 4y by minus 2xy. For this we get minus 2 by x. Now the integrating factor of 1 is e to the power integration of minus 2 by x dx. Then by integrating this, we can write e to the power minus 2 log of x, that is e to the power log of x inverse 2. From this line we can write 1 by x square. Now multiplying both sides of 1 by x square, we get 1 by x square plus y square minus 1 dx minus 2xy 1 by x square dy is equal to 0. Now simply calculate this, then we get 1 plus y square by x square minus 1 by x square dx minus 2y by x dy is equal to 0. Now consider m prime is equal to 1 plus y square by x square minus 1 by x square, and n prime is equal to minus 2y by x. Now differentiating m prime with respect to y and n with respect to x, that gives 2y by x square and n gives 2y by x square. That is equation 2 is an exact equation. Now integrating m prime with respect to x regarding y as constant, we get integration of 1 plus y square by x square minus 1 by x square dx. By integrating this, we can write x minus y square by x plus 1 by x, and there is no x free term in n, so our required solution is x minus y square by x plus 1 by x is equal to c. Now we will discuss about linear differential equation with constant coefficient. At first, we will see the auxiliary equation of a differential equation. For that, we consider d square y by dx square plus a1 dy by dx plus a2 y is equal to 0, and consider this equation as equation number 1. And y is equal to e to the power mx be a trial solution of equation 1. Now differentiating both sides of this equation, that gives dy by dx is equal to m e to the power mx. Again differentiate, that gives d square y by dx square is equal to m square e to the power mx. Now put this value in equation 1, that gives m square e to the power mx plus a1 m e to the power mx plus a2 e to the power mx is equal to 0. Now take common e to the power mx, that gives e to the power mx into m square plus a1 m plus a2 is equal to 0. From this line we can write m square plus a1 m plus a2 is equal to 0, and e to the power mx not is equal to 0, and equation 2 is the auxiliary equation of equation 1. Similarly, auxiliary equation of nth order differential equation will be m to the power n plus a1 m to the power n minus 1 plus a2 m to the power n minus 2 plus a3 m to the power n minus 3 plus an is equal to 0. Now we will discuss case 1. Find all the roots of a auxiliary equation are real and unequal. If m1, m2, m3 and mn are real and unequal roots of auxiliary equation, then the general solution is y is equal to c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x plus cn e to the power mnx. Now we will solve a mathematical problem for linear differential equation with constant coefficient. Like, solve the differential equation to d square y by dx square minus 3 dy by dx plus y is equal to 0. So write the given equation and consider the given equation as equation number 1. Now let y is equal to e to the power mx be a trial solution of equation 1. Now differentiating both sides of this equation, that gives dy by dx is equal to m e to the power mx, and d square y by dx square is equal to m square e to the power mx. Now put this value in equation 1. By putting this value we get 2m square e to the power mx minus 3m e to the power mx plus e to the power mx is equal to 0. Now take common e to the power mx. From left side we get e to the power mx into 2m square minus 3m plus 1 is equal to 0. From this line we can write 2m square minus 3m plus 1 is equal to 0, and then by the method of middle term we can write 2m square minus 2m minus m plus 1 is equal to 0. From this calculation we can write the value of m is equal to 1 and half. Here we see that the value of m, that is the root of this equation, is 1 and half, that is real and unequal. So by the case 1 we can write, so general solution y is equal to c1 e to the power x plus c2 e to the power x by 2. Here we have another mathematical problem to solve, like solve the differential equation d cube y by dx cube minus 13 dy by dx minus 12 y is equal to 0. To solve this, we write the given equation. If we write this equation by the operator d, then we can find d cube minus 13d minus 12 into y is equal to 0. Now let y is equal to e to the power mx be a trial solution of equation 1. Then we can find the auxiliary equation of equation 1 as m cube minus 13m minus 12 is equal to 0. Now we write m cube plus m square minus m square plus m minus 12m minus 12 is equal to 0. Now we take common m square from first two term, that gives m square into m plus 1, and then take common minus m, that gives m plus 1, and then take common 12, that gives m plus 1 is equal to 0. Now from this line we can write m plus 1 into m square minus m minus 12 is equal to 0. Now by the middle term from this part, that is m square minus m minus 12, that gives m square minus 4m plus 3m minus 12, and by calculating this part we can write m plus 1 into m plus 3 into m minus 4 is equal to 0. That is the value of m is minus 1, minus 3 and 4. Here we see that the root is different but real, so we can write the general solution as y is equal to c1 e to the power minus x plus c2 e to the power minus thrice x plus c3 e to the power 4x. Now we will discuss the second case. Second case applied when all the roots of auxiliary equation are real but some are equal. That is, if m1, m2, m3, mn are real and unequal roots of the auxiliary equation, then the general solution is y is equal to c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x plus cn e to the power mnx. That we see in the first case. But if m1 is equal to m2 and m3 is equal to m4, then we can write the general solution for the case 2, y is equal to c1 plus x c2 e to the power m1 x c3 plus x c4 e to the power m3 x and so on. Now we will solve a mathematical problem for case 2, like solve the differential equation d square y by dx square minus 6 dy by dx plus 9y is equal to 0. So we write the given equation and we consider y is equal to e to the power mx be a trial solution of this equation that gives dy by dx is equal to m e to the power mx and d square y by dx square is equal to m square e to the power mx. Now by equation 1 we can write m square e to the power mx minus 6 m e to the power mx plus 9 e to the power mx. Now take common mx e to the power mx and that gives e to the power mx into m square minus 6m plus 9 is equal to 0. And then by the calculation we can write m square minus 6m plus 9 is equal to 0, and by the method of middle term we can find the value of m is equal to 3 and 3. Here the value of m is real and equal, so the required solution will be y is equal to c1 plus x c2 e to the power thrice x. Now we have another mathematical problem for second case, like solve the differential equation d cube minus 2d square minus 4d plus 8 into y is equal to 0. To solve this, write the given equation and consider y is equal to e to the power mx be a trial solution of equation 1. So we get a auxiliary equation for equation 1, like m cube minus 2m square minus 4m plus 8 is equal to 0. Now according to the rules of remainder theorem, we can write m cube plus 2m square minus 4m square minus 8m plus 4m minus 8 is equal to 0. Now take common m square from first two term, that gives m square into m plus 2 and then minus 4m m plus 2 plus 4 into m plus 2 is equal to 0. Now take common m plus 2, that gives m plus 2 into m square minus 4m plus 4 is equal to 0. Now with the rules of middle term, from this part we can write m plus 2 into m square minus 2m plus 4 is equal to 0. That gives m plus 2 into m minus 2 into m minus 2 is equal to 0. So we get the value of m is equal to minus 2, 2 and 2. Here last two root, that is 2 and 2 are equal and minus 2 is different. So here we use second case as well as first case. So our required solution is y is equal to c1 e to the power minus twice x plus c2 plus x c3 e to the power twice x.